Good morning. Today we are going to study about some results. First one, some results or examples. First result, prove the following. Prove the following. First one, delta a f of x equal to a into delta f of x. Second one, delta f of x plus g of x equal to delta f of x plus delta g of x. Third one, delta f of x into g of x equal to f of x plus h delta g of x plus g of x delta f of x. And fourth one, delta f of x by g of x equal to g of x delta f of x minus f of x delta g of x. G of x divided g of x plus h g of x. These four results are proved. First proof. We know that delta y naught equal to y1 minus y naught. In similar manner, delta f of x can be written as f of x plus h minus f of x. This result is used to prove the first one. To prove that delta a f of x equal to a delta f of x. So we can start delta a f of x. So delta f of x equal to f of x plus h minus f of x, which implies delta a f of x equal to a f of x plus h minus a f of x. That's equal to a is common, so a into f of x plus h minus f of x. F of x plus h minus f of x equal to delta f of x. So a delta f of x. Hence the result. Then second one, delta f of x plus g of x equal to f of, by using definition, f of x plus h plus g of x plus h minus f of x plus g of x. Here f of x replace f of x plus g of x. One term. Okay, here f of x equal to f of x plus g of x. So f of x plus h plus g of x plus h minus f of x plus g of x. Then it's equal to f of x plus h minus f of x plus g of x plus h minus g of x. So equal to delta f of x plus delta g of x. So proof. Third one, delta f of x into g of x. That's equal to, here f of x equal to f of x into g of x. So written as f of x plus h into g of x plus h into, minus f of x into g of x by definition, using by definition delta f of x. Then f of x plus h, g of x plus h, we get f of x plus h delta g of x plus g of x delta f of x. Here f of x plus h and g of x are extra term. So adding and subtracting the terms, that is minus f of x plus h g of x plus f of x plus h g of x minus f of x g of x. Then comparing these two terms, here f of x plus h is common, so f of x plus h, then we get g of x plus h minus g of x, plus here comparing these two terms, here common is g of x, so g of x is common, we get f of x plus h minus f of x. So f of x plus h, g of x plus h minus g of x is by using by definition delta g of x plus g of x, f of x plus h minus f of x using definition delta f of x. So by hence result. Then fourth one, we have to prove delta f of x by g of x, that's equal to, using by definition, f of x plus h by g of x plus h minus f of x by g of x. Then cross multiplication, f of x plus h into g of x minus f of x into g of x plus h divided g of x plus h into g of x. Here then it's equal to, we get hence the result, we have extra term f of x and g of x, so we adding and subtracting that terms, that is f of x plus h g of x minus f of x g of x plus f of x g of x minus g of x plus h f of x divides g of x plus h g of x is equal to, here comparing these two terms, then g of x is common, so g of x, f of x plus h minus f of x plus, and comparing these two terms, here is common f of x, so f of x is common, then g of x minus g of x plus h by g of x plus h g of x, then we can rewritten as f of x plus h minus f of x is delta f of x minus, here this term is multiplied with minus, so f of x g of x plus h minus g of x, since by definition this is the delta g of x divided g of x plus h g of x, so equal to g of x delta f of x minus f of x delta g of x divided g of x plus h g of x. Hence the result, g of x delta f of x minus f of x delta g of x plus h g of x. Okay, then next result is result 2, find delta f of x and delta square f of x if f of x equal to a into b c raised to x. And solution, delta f of x equal to, by definition, f of x plus h minus f of x. Here f of x equal to a into b raised to cx. So f of x plus h equal to f of x plus h equal to a into b c x plus h. In place of x, x plus h can be substituted. Then a into b c x plus h minus a into b cx. Then here a into b cx b raised to h. That is b raised to mn can be written as b raised to m into b raised to n. So ch minus a dot b cx. Here cx is a dot b cx is common. So a dot b cx is common. Then b raised to ch minus 1. So delta f of x. Delta f of x equal to a into b cx raised to cx into b raised to ch minus 1. Then we can find delta square fx. Delta square f of x. Delta square f of x means delta of delta f of x. That is, we get delta f of x is a b cx into b raised to ch minus 1. Then by using definition, we get delta f of x equal to f of x plus h minus f of x. So here x in replace of f of, that means f of x plus h equal to a b raised to c x plus h. And here b raised to ch minus 1 is constant. So outside b raised to ch minus 1 is constant. Since it contains no x terms. Delta a b cx. Then b ch minus 1. Delta a b cx means a b c x plus h minus a b a into b cx b ch minus 1. So a b cx into b ch minus a b cx. So a b cx is common. So outside b raised to ch minus 1 a b cx b raised to ch minus 1. Again b raised to ch minus 1. Then combine these two. Then we get b raised to ch minus 1 whole square a into b cx. So delta square f of x. The next result. Result or example. Result 3. If u0 equal to 1, u1 equal to 5, u2 equal to 8, u3 equal to 3, u4 equal to 7, u5 equal to 0. Find delta square 5 u0. Find delta square 5 u0. Then we know that proof. We know that delta raised to 5 u0 equal to delta u0 equal to eu1. Sorry, delta u0 equal to delta can be written as e minus 1. So e minus 1 u0. Delta square u0 can be written as e minus 1 whole square u0. And delta cube u0 can be written as e minus 1 cube u0. So here delta raised to 5 u0 can be written as e minus 1 raised to 5 u naught. Then e minus 1 all raised to 5 means a minus b all raised to 5. A minus b all raised to 5 equal to a raised to 5 minus 5 a raised to 4 plus 10 a raised to cube a raised to 4 b raised to 1 a raised to 3 b square minus 10 a square b cube plus 5 a b raised to 4 minus b raised to 5. A raised to 5, here b raised to 0. 5 a raised to 4 b raised to 1 plus 10 a cube b square minus 10 a square b cube plus 5 a b raised to 4 minus b raised to 5. Then substitute this result. Then we get e raised to 5 minus 5 e raised to 4 plus 5 e raised to 4 into 1. 10 e square, 10 e cube minus 10 e square plus 5e minus 1 into u naught. Then we know that e square u naught equal to u2. That is e u naught equal to u1 and e square u naught equal to u2 and e cube u naught equal to u3 etc. Then e raised to 5 u naught minus 5 e raised to 4 u naught plus 10 e cube u naught minus 10 e square u naught plus 5 e u naught minus u naught. That's equal to e raised to 5 u naught u5 minus 5 e raised to 4 u naught, here u4. So 5 u4 plus here 10 u3 minus 10 u2 plus 5 u1 minus u naught. Then substitute these values. U naught equal to 1, u1 equal to 5, u2 equal to 8, u3 equal to 3, u4 equal to 7 and u5 equal to 0. Then we get u5 equal to 0 minus 5 into u4 equal to 7 plus 10 into u3 equal to 3, 10 into 3 minus u2 equal to 8, 10 into 8 plus u1 equal to 5. So 5 into 5 minus u0 equal to 1. Then we get minus 35 plus 30 minus 80 plus 25 minus 1. So we get minus 61. This is the result.